critica concrete,
Yeah, I think that's it.
I work in a design office with architect. We do a lot of that we call co-design. That means we initiate a project at the very beginning. The first drawing, the first conception done together with the architect, engineer and architect. And the goal is to design and to build a passive house project with ecological material, with renewable energy, especially in social housing area. And in France, also in other countries, social housing area is low cost normally. And it's very, very difficult to have the budget to make all of these goals. Passive house, ecological material, and renewable energy. And now I will show you one of the best projects that we built since 5 years. This is an 8-story building in Saint-Dié, in the Vosges. This is a 26 apartment, and it's based on CLT, cross-laminated timber, as a framing structure. Everybody see what's CLT?
It's the wood that we have as a structure in the...
Yeah, it's a little bit like the timber, but to do a wall, complete wall. You will see a short video about this material and some photos. And this is the highest, at the time of the construction, it was the highest housing building totally in wood in France. And this is probably one of the highest with straw-bale installation in the world. I will show you some concepts that allow to build this type of structure. As first concept is extreme sobriety, extreme simplicity in design, because you don't have to manage too complexity. This plan is very, very simple with two rooms, the living rooms, and all the technical room as the bathroom, toilets, and kitchen are very close together to have the minimum of fluids to manage in the building. And in fact, it's very interesting for the long lasting, because the rest of the building is completely dry. We don't have risk of leakage, we don't have risk of everything. And this is something that we begin to do 10 years ago, and now all of our design are based on this concept, to have to stack together the fluids and to have everything dry, and especially with wood and straw construction, that is very sensitive to moisture. This project is split in two buildings because of the shape of the area of construction. We don't be able to have only one construction, because the south is here, and the first is 3-story, and the second is 8-story. That's I was explaining the differences of the height of the two buildings. It's to allow all of the apartment to have the same exposition to sun for the passive energy income. This is just a short description of the structure. We will have more photo after that. All of the structure is with wood, CLT, cross-laminated timber, and all the insulation is in straw. And you will see how to do that. It's about 5,000 straw-bale. Some photo of the building. This is the CLT as wall and floor. As wall and floor. It's more known as timber, but it is the same system. You have a layer of wood, about 2 or 3 centimeters, and you cross the layer. You cross the direction of the fiber at each layer, and you reach a material very, very strong. In this building, 8-story, the thickness of the wall is 15 centimeters. 15 centimeters is less than concrete, because the wood in this way of building is more strange than concrete.
So 15 for the wood only? Structure.
Yes, only for the wood.
Okay.
And the secret of this building is in this box. This is the straw-bale box, and this is the key idea to be able to use straw-bale on such big project. When you use straw-bale to make a little house, 100 meters, it's easy and fun to handle the straw-bale by straw-bale, and to have loads of scrap of straw-bale everywhere. And I know lots of houses like this way, but you don't go this way if you have a lot. If you have a lot of storage, and if you have a lots of wall to do, because it's dirty and it's insecure. The straw in that form is very, very flammable, and it's a real problem. And the idea was to do a packaging. This packaging is very, very simple design. This is a box at the side of the panel, 2.5 meters, 1.2 meters. This is the standard size of the panel. And on the ground, you can stack 5 straw bale into the box. And after that, you close the box, and we have two hooks, and we take the box and put it directly on the building. You will see on a short video, and that seems to be very, very simple, very low tech. And in fact, this is the key of the building, because all of these panels are DWD. As you know, it's medium fiber with latex. This is waterproof, and that allows to handle the box under rain or under snow. And another aspect of this box is that the box was not done by the carpenters, but done by an industrial that make normally packaging to ship goods, machine, something like that. And that's very interesting because it's very, very cheap. They are very, they make usually big quantities of boxes, and they have special machine to make the box with a few efforts. And in fact, this is the first key is protection of the straw-bale, handling, and second key is economic, because in this way, the total complex of installation is about the price of polystyrene. In fact, this is the cheapest material and the less sustainable.
Like, how much is one box?
Sorry?
How much is one box?
At price?
Yeah.
I think it's about complete. It's less than 100 euros for 3 square meters. 3 square meters of wall insulate on the building. Because there is a lot of other little ideas like the panel, the finishing panel that will be outside is made with stick of woods that are the structure to receive the tilts of the facade. And we don't have to put this stick on the building because it's already down with the box. It's all of little ideas like this that make big saving and make easy to use this material. Because the only problem of straw bales, this is the handling. If you find idea for the handling, you can do everything with straw bale. But if you have to use the straw bale by themselves, it's very limited to self-construction, for alternative construction, but you can't use it with big company on big project.
Sorry, but I don't know, but in comparison to like a normal fiberglass insulation, like how much is like 3 meters square of fiberglass?
In fact, I understand the question, but I can answer that way because this is also a structure to handle the tilts of the facade.
The tiles.
Tiles. You will see. This is the way to handle it. It's very, very fast.
How do you fix it in the machine?
With a screw.
For
outside, you screw it on into the wood.
They are built already with the straw. In place.
Yeah. This is the idea, to go on the side with the boxes complete.
Yeah.
You will see a short video about that. Just because in my job there is the design of the structure with the architect, and there is also all the fluids and heating, hot water, ventilation, everything. But this is just a photo of the technical room, just to have in mind. The building is the Vosges. This is the mountain. It's in the German border. It's one of the coldest parts of France, and we have only a little heat pump with 30 kilowatt power. That means 1 kilowatt per apartment. It's very, very, very low. 1 kilowatt power, it's a little radiator like this. And with this machine we do heating, hot water. We have a lot of. This is not the point of my lecture of today, but we have other very interesting idea, like energy recovery of the waste water. All of all of the washroom, hot water of the
Shower.
shower come into the same place in the technical area, and we have a big copper coil exchanger that recover almost all the heat of the shower, and sometimes on annually based, we have 40% of the heating of the water that comes from the shower, from the recovery, and at instant based, with everybody take a shower at some time in the day, we can recover about 70%. And this system is very interesting because, in fact, more shower do you have, more parts of heat you can recover. And in fact, the big balloon, there is a big balloon of water. It can't go less than 45 degrees because of this system. And it's very, very economic because it's only, I think I have a photo to that.
How rare or how common is it to have that sort of system of recuperating the heat from the showers?
It's very, very simple. It's a cross-flow copper exchanger.
Okay.
Only, I think
Is this rare? It's rare.
all the wastewater that fall into a PVC tube normal, and at the ceiling of the technical room, you have a copper tube, and around this copper tube, you have a little tube that's welded on it with the clear water, the fresh water.
So you preheat with the coil.
And the fresh water absorb the heat of the wastewater.
From the PVC?
Like the PVC,
No, no.
like
No, it's not the copper.
For the copper.
Oh, right. Yes.
I researched after that. I have a photo of the system. Just to have a look at one apartment. We don't have curtain to protect because in the Vosges in winter we have -20, and in summer we have 40, possibly 42. Last record, and we don't use curtain to protect because we are completely south orientation, and we use the balcony to make the protective shading. This is a photo nearly. It's a photo in winter. It's nearly the solstice, and you can see that exactly all the glazing are into the sun ray, and in the other solstice in summer, you don't have any solar ray into the glazing, and this is completely without action, and you have all the solar income in winter and no in summer.
So did you like change the orientation of the building depending of the sun?
No. This is completely south. We are south.
Change the sun.
We check for each other.
There's an app for
In fact, this measure and this measure has to be adapted with the latitude.
So,
This is the only thing you can change. Not the sun, not the building.
exactly. There is like it's from a particular country, I guess, or it's just you made it, or
No. It's in this place. It's the latitude is 48 degrees north, and here we are 41 or 40, something like that.
Yeah, should I check?
It's 41. It's 41. And if you go in Africa near the equator, the sun is 0. It's and in fact you don't have to protect the south or the north. You have to protect east and west. It's completely different design, but this is the same way to protect or to use the sun as you need. Another look of the results of this solar geometry in the living room and the presence of wood, everything, because we have also big timber to make the load varying. And before the 2 little video of the straw-bale and all of the building, one of the first reasons to do a passive house for social housing is to have the lowest cost for the people that live into. The lowest total cost, because it's easy with technology to have low energy cost, but you have high maintenance cost, high technology cost, and the goal is to have the 2 lowest as possible. This is the real cost after 1 year of use. And the other year was the same. This is per month. Total cost for heating, hot water, electricity of ventilation system, and all the maintenance of energetical system. This is 13 euro per month. In comparison, do you have the cost of this is tax of
For the trash, like
trash
collection.
trash collection? This is more.
For how many square meters? The flat of how many?
It's
70 to 90, I think.
yeah, exactly. Depends on the size, but it's about 70 and 90. In France, in this area, this is nearly 0. In fact,
Okay.
a normal flat, it's about 100 per month.
So it's electricity or gas?
It's only electricity because you have a heat pump. And all the, I don't stress on it, but all the systems are collective. We have quietly nothing into each apartment. In the way to be the more dry as possible. We don't have radiator, we don't have heating on the floor. It's only a little heating battery to preheat insulated incoming air. The fresh air is preheated by a little battery, and the heat of the battery comes from the heat pump.
Yes.
Non, c'est pas intéressant. Okay, the finish, and it's another little idea, but very interesting. It was a question how to lower the cost of the cutting, the herb cutting, the grass cutting, because in normal system you have to go 7 or 8 times per year to cut the grass, and the idea was not to have grass, but to have Alors, pareil, je sais pas comment c'est dit en anglais. Jachère fleurie.
Je connais pas ça.
I can describe. It's a mix of wild seed, flower, of different things, and you put it just after the construction. And first year something comes. And you let it at that high. Just at the end of summer, you get it, and last year you have other things, and the year after other things. In about 4 years, you have after 4 years you have always the same, and it's less nice, but you can go back and re-put mix of seeds and so on. And it's very interesting because everybody, the people into the apartment, the social housing company, the politics, everybody feel this very, very, very well. It's very interesting.
Can I ask you what's the coating on the balcony, on the side, the white stuff?
This
This.
This is metal. This is metal with paint. Yeah. Because we have. This is another point very interesting. The actors of the project, the Travaugiens. This is the building house company, the social house company, and this is industrial of the area that make a house for the worker. And there is a state of mind to use only local company. Little company and local company, and lots of parts of this come from local company, and this is always the reason that we use it.
Sorry. The metal, it's a metal sheet glued on, fixed on the wood structure.
No.
All the slab is metal.
All the balcony, you will see on the video. All of the balcony are with a self foundation bearing. It's only some screw to fix it, but here we have a little concrete. Foundation.
What's the vertical structure of the entire building made of?
What?
All of it is made of wood?
All of it.
Okay.
Completely. You will see with the video, it's very, I think, I will show you the 2 little video, and after that we open the discussion. Okay?
Il y a que ça qui compte, qu'on soit homogène, sans vide, au-dessus de 100 kg.
Des caissons remplis de paille. Mais pourquoi faire? Isoler un immeuble de 7 étages, le plus haut immeuble de France, voire d'Europe, avec une structure bois et une isolation en paille. Pour y parvenir, 10 hectares de paille sont nécessaires pour fabriquer 700 caissons.
On a vraiment une filière très très simple et très très courte qui part du champ, avec un motelage classique, une mise en œuvre très basique et très simple, avec un assemblage de panneaux aux dimensions standards aussi.
C'est un caisson qui a la forme exactement pour 5 bottes. On sent bien l'homogénéité de la pression tout simplement en marchant dessus. Et en ouvrant les bottes de paille, la paille s'expanse de chaque côté et remplit tous les interstices. Et ce qui fait que, bien que la botte à l'origine est un petit peu plus courte, à la fin on a une densité qui est homogène et on n'a pas de vide. Ce qui est impératif pour la mise en œuvre d'un caisson paille.
Objectif, construire avec des produits sains, renouvelables et de façon économique. Ce système de caisson va permettre de réduire considérablement les coûts. Un mois plus tard, la pose de l'isolation est quasiment finie.
Donc là on a sur l'ASMI qui est ici en bas l'ensemble des caissons qui sont en train d'être déchargés. On a un remplissage optimum du camion puisque 2 largeurs de caissons font exactement la largeur de la remorque du camion. ce qui permet vraiment d'être sur des éléments standardisés et ce qui est vraiment le côté économique de la chose. C'est-à-dire qu'on optimise le transport, on optimise le levage, on optimise le montage.
Les caissons sont posés les uns sur les autres, un peu comme des briques.
Une fois qu'il est posé sur son petit frère qui se trouve en dessous, il est à ce moment-là vissé sur la façade de façon latérale, vissé par le dessus, donc en oblique sur la façade. Et puis on a de nouveau des fixations mécaniques qui sont au nombre de 8 pour les gros caissons et de 6 pour les plus petits.
Les caissons participent aussi à la structure du bâtiment.
Il y a un point qui est très important, c'est que dès qu'on est dans des bâtiments performants avec un système d'isolation par l'extérieur, on est dans des épaisseurs importantes. Épaisseurs importantes, ça veut dire qu'en fait, on éloigne notre bardage ou notre vêture, qui elle pèse un certain poids, de la structure principale. Donc du coup, on se retrouve avec des risques de cisaillement et donc la nécessité de recréer, on va dire, une deuxième structure pour porter la vêture. Là, en l'occurrence, c'est notre isolant, notre principe d'isolant qui fait cette structure-là. Et c'est là où, effectivement, on arrive à être performant économiquement.
Ces caissons seront recouverts de tuiles en terre cuite, comme sur ces maisons à proximité. Dans la même veine, un deuxième bâtiment plus petit sera construit juste à côté. Au final, 26 logements sociaux de 76 à 90 mètres carrés.
Vous êtes en logement social, là vous avez des financements plus et PLAI, donc on y logera aussi des familles à fort bas pouvoir d'achat, c'est tout à fait normal. C'est un programme qui a été aussi fait dans le cadre de l'ANRU, dans la rénovation du quartier de Kellerman, que vous avez derrière, donc qui est juste à côté. L'intérêt pour nous, c'est que nos locataires aient le moins de charges à payer.
Panneaux solaires, géothermie et VMC double flux, tout est prévu pour faire baisser les charges. Pour un 90 mètres carrés, elle ne devrait pas dépasser 130 € par an, hors électroménager. Ce bâtiment atteint les normes thermiques du label Passive House, 2 fois plus performante que celle du BBC, et pour un coût comparable, environ 5 millions €. La filière bois-paille dans la construction est en pleine révolution.
little graphic. Do you have? It's not complete, but it's some kind of life cycle analysis of this building. And do you have in green that is a net storage of CO2, of carbon, because of the wood, the straw, you have a little bit of cellulose, and you have the emission with concrete, steel, and a little bit with the glasses and terracotta.
The tiles.
Tiles. It's
the clay tiles.
earth, cooked earth.
Yeah.
In fact, the 1,000 cubic meters of wood. This is a giant quantity of CO2 that is stored into the building.
Okay. But this is the footprint of
Yeah, it's the carbon balance. This is the carbon balance.
Okay.
Of like, so the positive, what is captured into the material.
Yeah, this is in fact
and the cost.
Here is in negative because this is the storage, and here do you have the emission?
Is it clear? So it's a positive footprint.
But like
1,000 tons.
of this building.
Yeah.
But no, the question goes into what happens if you would have made it out of concrete or if you would have made it out of steel.
Okay.
I'm taking into account that the wood comes from Australia.
In France, we don't have at that time the industry to make this CLT panel because Australian like Kailash have 20 years forward of production. They are very good at that, and in France it's difficult. It's easy to have a lot of concrete, but nobody wants to make the little plant to manufacture this panel.
Okay.
And do you see like an alternative in a concrete foundation in the future in seismic area?
Very difficult because in fact the problem with the seismic area of this building is that the building is too light, and we have the foundation and the steel you have here. It's a big part of steel to hook the building into the ground, because in case of big earthquake, the building will lift.
I have two questions. One's about, I saw there was a slide, but we went past it, about the fire resistance. Like, how do you certify that? If it's like a lot of wood and straw. And second is, you said that region goes to -20 Celsius in the winter. How effective? Like, I'm from Quebec, so I'm wondering if, how efficient is insulating with only straw and nothing else? Yeah.
I get that. I get that.
At -20?
Yeah. Okay. There's a lot of questions. Yeah. First, for the fire. Fire. Yeah. Two answers. One, the structure is classified 2 hours. 2 hours stable at fire, because in fact we use one more thickness of wood to protect the structure, and we have 2 hours of burning before structural failure, and this is the French regulation. And this is for the wood and the structure, and for the straw-bale, it's very well known now because we have a lot of tests. The German done a lot of tests 10 years ago, and now in France also, because we are several schools in straw. We done a college, a big school, and there is a lot of tests that show we have between 1 hour and 1 hour and a half of fire resistance, and it's enough for this type of building.
Why? Is it the wood or is it something that it has a finished product?
No, only the straw-bale because of the density of the fiber.
And the lack of oxygen because it's in a
it's
box.
like if you try to burn a big book.
Yeah,
and a straw-bale at 130, 150 kilogram density per cubic meter, it's like a book.
But you have one thing there. So normally with straw-bale, it's already compressed, and normally you compress a little more for construction. And here you put it inside a box and you open it.
Yeah, but
So
I use high density straw-bale, about 150 kilograms per cubic meter.
So
and also you have the box that also.
Has a resistance.
Another question.
Yeah. It was the second question.
Yeah,
the
sorry.
minus 20. Straw-bale are lambda. Do you understand? The lambda, the
conductive resistance.
Coefficient. It's 0.05. It's nearly the same as other material, except polyurethane and so on.
And so why is it not more commonly used in cold countries?
Yeah, it's used in Canada.
Yeah.
A lot?
Yeah.
Very much.
The first experiment was in Canada.
Yeah, but is it common? Like in most countries?
No, it's not common because if it was common, I don't be here to present how to use straw-bale. No, but for our design office and for the architect, what we design it, it's common. We do perhaps a third of our building with straw-bale. But it's just a different way of designing. You have to make the packaging that way. We done lots of different way to use. We done winery with very big bale and plaster and without wood. It's a different way. In each project you have a different design based on the material. You can't design a building like this as usual, and after that, it's great, the straw-bale. No, impossible. you have to the idea of the straw-bale, and after that you find each details. Yes.
So let's go to that one. So you're saying that lambda is 0.05 for how much thickness?
No, this is the lambda. This adimensional. This is the quality of insulation.
Okay.
It's in comparison with the other.
So
Here we have a U value of 0.1. Yeah.
For how much thickness?
Total wall.
Yeah.
Total wall is
just
total wall is 55 centimeters. Because the CLT also is a little part of the insulation.
Of course. But how much is the U for only for the straw-bales?
Only for straw-bales, I think 0.15. 15.
The other question is about the fire resistance for the wood. I'm asking this because here in Portugal it's really difficult to work with wood, exactly because of that. Most of the time we have to paint with a special kind of paint that protects the wood. So is that wood already with some kind of protection?
No. But the question is about the fire resistance of the wood, not as a physical element, but with the regulation. Because it's, and I think I will not have a complete answer because this is a very big subject. There is a lot of different ways to explain. I talk about fire stability. And fire stability, it's not fire resistance. Fire stability, this is in, we are 2 hours stable on fire, that means you make a big fire into one apartment. 2 hours after, there is no problem with the stability of the building. You have enough time to take every people outside and so on. This is the French regulation.
Yes, finish the pasta.
We have no chemical product on the wood. The wood is completely natural into the apartment.
Questions?
Yeah, I have one. Regarding the straws, so right now agriculture is being a big impact in Earth because of all the water that it needs. So what is like life cycle assessment balance regarding the strays and being food for animals rather than using it for building?
Another very interesting and very big subject. In fact, the animals don't eat straw.
But in Mexico they do.
They eat hay.
What's the difference?
Hay, it's grass, and straw is from
the wheat. Is that?
And it's completely different because you can't build with hay because hay is totally unstable. It's flammable, fermentable. It's for animals.
Okay.
So this is the lunch of animals. And as a production, the real question is why we don't have so little straw and at the same time to have so many hectares of wheat. It's very simple. Before the mechanization of agriculture, the straw was very high value because you use straw to make roof, you use straw to make everything. And with mechanization, with the harvesting, if the straw is too high, the wet fall, and after that you can't use the machine. And all the selection and the chemicals and everything in industrial agriculture is to have the shortest straw as possible. The question is good, but the problem is not with the use, the problem is with the agriculture. And in fact, the straw on the field costs almost nothing in actual agriculture. It's reality.
Just one.
In France.
Sure. No, go. One final question. I missed it. You don't add anything to the straw to make these blocks. There's no additives to fire retardant, humidity.
Nothing. I think.
So what would happen if one of these were had a fissure and water got into it? Chance of mold and humidity and it goes below 20.
During the building, we had rain, we had snow, everything. Yeah. And we on special boxes, very wet during the building. We make some little hole the basement, and we use an humidimeter, and we put it into on nearly 20 boxes. And we don't measure any significant differences between the very dry straw of the beginning.
No. What are the boxes made of? Is it what type of wood? Is it the same type of wood?
Sorry?
The boxes, what are they, what type of wood is the box?
The wood? Yeah. It's BWD. It's medium fiber with latex. It's waterproof.
Okay.
Is it a compound wood?
And is it like MDF?
It's not a natural wood.
It's MDF with latex.
Is there an alternative to that? Because MDF is like extremely unsustainable.
It is and it's not. It's also like made with leftovers of leftovers of leftovers.
It's also like impossible to degrade.
In fact,
it's true. It's true, but it's like really the end of the
step by step.
Yeah.
I'm just saying. Could you imagine like
we can imagine to use rough wood.
Okay. But is the MDF or the DWD like it has properties that makes the insulation of the box more effective than
a little bit. Okay. It's a little bit better than to use wood. But the real reason is that it's very easy to use and not expensive and waterproof and easy.
Do you know if the efficiency of the isolation, I mean, after 10 or 20 years, is it still the same, or do you think after 30 years the straw is a bit disaggregated, or can we replace it, or do we have a way?
That's a very good question, and in fact, if you ask this question about all of the other insulation system, the answer is not very interesting because it's not long-lasting. We have a big chance with straw-bale because the history of straw-bales is not the point of tonight, but it's very interesting because this is different innovation at different parts of the world. And in France, in the beginning of the 20th century, it was a housing project with straw-bale and prefabrication. And we have in Terranergie, it's near Paris, we have a straw-bale house built in 1921, still alive, and with the straw in very good condition. In fact, it's very simple to understand. The very first building of the humanity was with straw and clay, and if the straw is maintained under 20% of humidity, air humidity around, or 80% in fiber humidity, this is fossilization. There is nothing, no bacteria, no fungus. The insulation of straw-bale, if you avoid humidity, if you avoid moisture, it's never ending.
If you need to change one of these panels because they're modular, is that an easy task, or would it be something happened that they broke and you need to change?
I think it will be easy because we just have to remove the tiles, and after that, perhaps something to do to extract. It was already done because in my history with the 20 test, in fact, in one part at the beginning here, it was something with the temporary water evacuation. It was a break and the tubes come just into the last box here, and all of the box was with moisture, and it was obvious that it was to replace. And in fact, we don't move the box. We open it with a saw. We change the straw-bale, and we put a new DW patch. And we use some white glue to make the ceiling, and it was done. In fact, in reality, it was already done.
And the blue circle?
Okay, this is just security. It's it comes from a previous project that we use. This is straw-bale 1.2 meters by 2 meters. It's a very big straw-bale, and we use it as external insulation on one building. And we use a lot of pin like this. And this is one part in polyamide, and with a screw at double, like sarking screw. Do you see sarking screw to make insulation on the roof?
Okay, yeah.
This is quite the same system. And here, this is security, just in case.
Security for what? Security for what?
For if one straw bale will a little bit move, slide into.
Okay, so it's a hook.
It's like a reinforced.
Okay.
Reinforced.
How I saw the machine. I think the most important part is the common infrastructure. So I think my question is that much effective because it's a common thing for that much apartments? Because when you build only one house with passive system, it's really different. And you have the same kind of maintenance, and you have to, so the difference between having a common thing for that much apartments, when do you think it really, what is the number when it really becomes sustainable or more efficient?
For us, it's obvious. We don't use individual system on collective building. It's nonsense. And if you want to manage and to know if it's normal, you are in normal condition or you have some problem with the system, you have to have the simplest system as possible. And here we have only one heat pump, and the other part of the tech area we have only one in passive house, especially in very cold area. We need to use preheating of fresh air with waste air.
So all the air goes through that?
Yeah, everything. This is the complexity of the design. But the machine is not complex. The complexity is to collect 26 compartments for fresh air and for exhaust air, removed air.
Just to have some numbers. For that, I have 13 euros per month, I think it was, for the amount of, to have everything for each apartment. If I have the same kind of system with the dimensions for only one house, how much would be? Just to make the difference between a big apartment complex and one house only.
It's difficult to answer because we have a lot of in a collective building. We have a very good capacity, and in fact, to have the same performance, perhaps on a single house, we need to have twice the insulation. Perhaps we need to have windows from the space. Windows very expensive. Here we have very good triple glazing, but it's standard triple glazing. It's not passive windows with insulation on it and so on. This is all a different philosophy. In fact, we don't build single passive house.
Okay.
Because it's too high cost. Yeah, exactly. And nonsense, in fact, because example in the bush, we can use a little fireplace, and it's easier.
Exactly. Just one thing, I like very much that system. I knew that from another thing, but I think it's okay. But what do you do with the water? Do you have some kind of a grey water reuse, so harvesting or something like that?
No.
Just that.
Good.
Done.
Thank you very much.